Hi guys, so this is me making a video on how to do the investigation, the force of gravity. So for this investigation, you should have opened the assignment in Kami. You should see the assignment, it looks like this. The first thing we're gonna do is read the question, how could you increase the force of gravity? So in this lab, you're trying to kind of figure out what factors would change the force of gravity for an object. So we're going to go online and explore the PhET Interactive Simulation Gravity to Force Lab. When you click on this link, so you'll use this tool to click on the link right here, it's going to open up to the Gravity Force Lab. After exploring the simulation on your own, reset the simulation and follow the instructions below. So the first thing we're going to do is we're going to determine how to change the force of gravity on one object, this one on the right. This is the force of gravity that it's experiencing. This number right here is 0.000000166,852 newtons. That's a really small number. That's how much force that this object is experiencing. It's being pulled over here by this object. So how could I change the force of gravity on this object? In the graphic organizer below, circle the word that best describes your observations on how the force of gravity on the object on the left changes. So what I'm going to do right here is I'm going to change the gravity on this one by just changing things. I notice that when I move this one closer, the force of gravity changes. It looks like as I move it closer, the force of gravity is increasing. It's getting bigger. This number is getting bigger. So notice that when you do this, it says when the force of gravity changes on one object, the force of gravity on the second object always changes by the same amount or a different amount. So notice these numbers right here as you change the force of this, as you change the force of gravity by moving the objects, are the numbers always changing by the same amount? Or is there ever a difference in the amount? So when I do this, you notice it's always the same amount. The force of gravity is always equal on both objects. The force exerted by this object is equal to the force exerted by this object, but opposite in direction. So this should sound like one of the laws that we've been talking about, one of Newton's laws of motion. The next thing we'll do is we're going to follow the instructions, move the object to the right closer and farther away from the object on the left. So as we move this one around, we're trying to notice what happens to the values. What happens to the amount of force, how strong of a force. So now I want you to complete the graphic organizer below by using one of these two words, increase or decrease. If the force of gravity is increasing, that means it's getting stronger, and you would see the number getting larger. If the force of gravity is getting weaker, then you would see the number getting smaller. So you're going to do this right here. You're going to decrease the distance between the two objects. So when I say decrease the distance, I mean you're going to take your two objects and decrease how far apart they are by moving them together. So then bring these two objects together and tell me, is it an increase or a decrease on the force of gravity? And is it the same for both? Are they both increasing? Are they both decreasing? Or is it different? What did the numbers show you? We're collecting data here. Now do the same thing here, but it's the opposite. You're going to increase the distance. You'll move the objects away. On question 4, you're going to increase the mass of the object on the right and then decrease its mass. So you're going to decrease the mass, then increase the mass. You're going to tell me what happens to the force of gravity again. Is it an increase or a decrease? Finally, you will explain why the force of gravity is the same on both objects. Why is it that no matter what you do, whether you're changing the mass or the distance, the force of gravity is the same on both objects? Why is it when one pulls on another, the other object pulls back with an equal force, but opposite in direction? So what I want you to do is explain that to me here, and do that by restating which one of Newton's laws is applying.